Hi, my name is Shawn Toothman. Come and see me. I'm at Phoenix Auto Parts here in Phoenix, Oregon. Give us a call at 541-535-8300.
Old lady from Pasadena.
Hi, I'm Bill Kiefer, and I have a classic 1989 Ford Mustang, red, and I only trust Shawn at Carquest Auto Parts in Phoenix to get my parts. Be there or be square.
The PCV valve is usually located next to the valve cover of the engine or in the intake manifold. If you cannot identify it quickly, check with the workshop manual. Switch on the ignition and start the engine. With the engine idling, pinch the hose attached to the PCV valve hard enough to shut off the supply of air through it. If the valve is working correctly, the idle speed should drop enough for you to be able to hear the change. Alternatively, remove the hose from the PCV valve attached to the valve cover, leaving the valve in place. And putting your finger over the opening of the hose, you should feel suction. Remove the hose and check that it is still pliable and not clogged with sludgy deposits. If the hose cannot be cleaned easily by blowing some air through it, then it should be replaced. Remove the PCV valve and inspect it for deposits. If it can be taken apart, then you can clean it with PCV solvent or lacquer thinners. If it cannot be dismantled, but has restricted operation because of sludge, then replace it with a new one of the same type.
If a coolant boils, it can be as serious for an engine as having it freeze. Boiling coolant in the water jacket becomes a vapor. No liquid is left in contact with the cylinder walls or head. Heat transfer by conduction stops, heat builds up, and that can cause serious damage. One way to prevent this is with a radiator pressure cap that uses pressure to change the temperature at which water boils. As coolant temperature rises, the coolant expands, and pressure in the radiator rises. It soon rises above atmospheric pressure, and that lifts the boiling point of the water. Engine temperature keeps rising, and the coolant expands further. Pressure builds against a spring-loaded valve in the radiator cap until at a preset pressure the valve opens. In a recovery system, the hot coolant flows out into an overflow container. As the engine cools, coolant contracts and pressure in the radiator drops. Atmospheric pressure in the overflow container then opens a second valve, a vacuum vent valve, and overflow coolant flows back into the radiator. And that stops atmospheric pressure collapsing the radiator hoses.
Locate the adjustment fastener and loosen it. This is usually on the alternator mounting or on a separate pulley wheel. Move the adjusting mechanism in far enough to allow you to remove the belt. Some vehicles use an automatic spring tension system. In that case, pull the tensioning device back so that you can remove the belt. Check the drive and pulley wheels. Look for cracks and other forms of damage. Check that there is no sideways movement indicating worn bearings. And spin the pulley wheels by hand to check that the bearings are rotating freely. Obtain the correct size and type of replacement belt specified in the workshop manual and compare it with the belt you have just removed. They should be very similar, although the old belt may have stretched in use. Install the new belt, making sure that it is properly seated in the V-shaped groove or the multiple grooves in the pulley, depending on its construction. If the belt is a serpentine type, then make sure that it is the correct width and squarely aligned in the pulley grooves. If it is not correctly aligned, the belt will be thrown off the pulley wheels. Tension the belt using a wrench and a pry bar. Then check it with a tension gauge. With automatic tension systems, gently allow this to apply the tension to the belt. Start the engine and observe the belt to make sure that it is properly seated and operating correctly. Stop the engine again and recheck the tension.
Thank you very much for watching.
Refer to the Vehicle Service Manual to identify the location and type of fuel filter and the correct procedure for removing and replacing it. If the engine is fitted with an electric fuel pump, locate the fuel pump fuse using the service manual and remove it. Start the engine and wait for it to stop as it runs out of fuel. Switch the ignition off. Obtain the correct replacement filter and components. If the vehicle has a carbureted fuel system, new intake and outlet hoses may have been supplied with the filter. If so, then attach them to the new filter before you disconnect the old one. Loosen the clamps on the fuel line on the engine side of the filter at the outer end of the hose and disconnect it. If necessary, drain any excess fuel into the fuel-proof container. Connect the new filter hose and tighten the clamp. Make sure that you have the filter facing in the right direction, with the flow indicator arrow pointing towards the engine. Then remove the old filter and reconnect the new one to the fuel intake. If you do this quickly, very little of the residual fuel in the line should leak from the system. In a fuel-injected system, the fuel is under greater pressure, so the fuel lines are normally made of metal, which are not replaced at the same time as the filter. Using the correct tool, loosen the metal line connectors and remove the filter, catching any leaking fuel in a fuel-proof container. Connect the new filter and tighten the line connectors. Make sure that you have the filter facing in the right direction, with the flow indicator arrow pointing towards the engine. Finally, remember to replace the fuel pump fuse. Before removing an oil filter, first refer to the service manual for the vehicle and identify the type of filter required. Make sure that a suitable filter will be available as a replacement. The filter will usually be located on the side of the engine block or at an angle underneath the engine. Some filters have a retaining nut which will require a box wrench to remove it. But most late model vehicles have filters which are threaded cartridges. These are removed with an adjustable filter wrench. Remove the filter and clean the seating area on the engine so that its surface and the surface of the new filter can seal properly. Make sure that the seal from the removed filter is not still stuck to the engine. Confirm the correct part number and obtain the replacement filter from your spare parts supply. It is good practice to fit a new filter every time you drain the sump. Smear a little oil or grease on the surface of the new sealing ring. This will help to make a tight seal, but it will also prevent the gasket from binding and distorting while it is being tightened. Screw in the filter until the two surfaces are touching. To help judge the correct degree of the turn, make a mark on the outside of the filter with a pencil or even a dab of oil. But remember to wipe the oil off again when you have finished. Do not over-tighten the filter. Typically, 3/4 of a full turn is adequate torque for a seal that will not leak. Prepare the vehicle by removing any hubcaps or lug nut covers. Loosen the lug or wheel nuts while the vehicle is still on the ground, and raise the vehicle to a comfortable working position. This practice can lead to the wheel nuts or studs going on cross-threaded. Once the nuts or studs are ready to be torqued down, refer to the shop manual for the correct torque and tightening sequence. Typically, the lug nuts are tightened in a diagonal sequence on 4 stud wheels and in a star arrangement for 5 stud wheels until all the nuts are tight. However, there are exceptions, so the manufacturer's recommendations should be referred to. This should be done to a specification of 50% of the recommended torque for the first stage, and then to 100% of the specification at the second stage, using the same tightening sequence for the particular wheel. First, make sure that the gas flow from both the oxygen and the acetylene cylinders is turned off tightly. The 2 cylinders are secured in an upright position. This is usually on a wheeled trolley. Look at the hose pressure and cylinder pressure gauges on top of each cylinder. Both gauges on each cylinder should read 0. If both gauges do not read 0, turn the main cylinder valve on the top of the cylinder clockwise to close it completely. Then you must purge the system of any gas. To purge the system, make sure the main cylinder valve is closed tightly. Pick up the torch handle and note that it has 2 hoses attached. One hose supplies acetylene, the other oxygen. Turn the oxygen regulator under the gauges clockwise and open the oxygen valve on the handle. This will purge any gas that may still be in the system, and the gauges should both drop back to 0. Repeat this procedure with the acetylene cylinder. The torch handle is the connection between the hoses and the working tips. It consists of a body and 2 taps. It's used for both welding and heating. Different attachments are connected to the handle to enable welding, heating, or cutting. Examine the connections. One connection is marked OX and is for the oxygen hose. The other is marked AC and is for the acetylene hose. As a further safety precaution, you'll find the oxygen connector is right-hand thread, and the acetylene connector is a left-hand thread. Welding tips come in sizes that are stamped with a number. Number 1 is the smallest tip. The larger the number, the larger the tip and the greater the heat that it will provide. Select the tip size suitable for the heating task and screw it onto the end of the torch handle. Hold the torch handle in your hand so that you can comfortably adjust the oxygen and acetylene taps. Position the tip so that it faces away from you. Gently tighten the tip securing fitting. You are now ready to adjust the gas pressure for heating. Look at the 2 valves on the torch handle. The valve next to the oxygen hose controls the flow of oxygen to the tip. Close it tightly clockwise. The valve next to the acetylene hose controls the flow of acetylene to the tip. Also, close it tightly clockwise. Now that you're ready to use the torch, turn the main valve on the top of each cylinder counterclockwise half a turn to open the valve. The needle on the cylinder pressure gauge will rise to show you the pressure in the cylinder. Turn the oxygen regulator handle clockwise until the needle in the gauge registers 10 psi. Turn the acetylene regulator handle clockwise until the needle in the gauge registers 5 psi. This is your working pressure for heating. Before you light the torch, check the area you're working in to make sure there are no flammable materials or fluids nearby. Workmates should also be clear of the area. The welding flame is not only extremely hot, it also produces dangerous ultraviolet rays, which will damage your eyes. It is absolutely vital that you are wearing the right safety gear, gloves and tinted goggles or face mask, so put them on and adjust them comfortably. Now you are ready to ignite the torch with the striker. The tip of the torch must be pointing downwards away from your body and away from the gas cylinders. Turn the acetylene valve on the torch handle slightly towards the on position. You should hear the gas hissing. Hold the striker against the tip of the torch with the lighter cup between the torch and you. Flick the striker to create the spark that will ignite the gas at the tip of the torch. Open the acetylene valve slowly until the sooty smoke produced by the torch disappears. Then slowly open the oxygen valve on the torch handle. As you open the oxygen valve, you will see the color of the flame change. The pure acetylene flame is yellow, and it will change to blue as you add the oxygen. Continue to open the oxygen valve until you can observe a small, sharp blue cone in the center of the torch flame. This is the neutral flame you need for general heating. Most light vehicles use a single plate clutch to transmit torque from the engine to the transmission input shaft. The flywheel is the clutch driving member. The clutch unit is mounted on the flywheel's machined rear face, so that the unit rotates with the flywheel. The clutch unit consists of a friction-type disc with 2 friction facings and a central splined hub, a pressure plate assembly consisting of a pressed steel cover, a pressure plate with a machined flat face, and a segmented diaphragm spring, and a release bearing and operating fork. The friction disc is sandwiched between the machined surfaces of the flywheel and the pressure plate when the pressure plate is bolted to the outer edge of the flywheel face. The clamping force on the friction facings is provided by the diaphragm spring. Unloaded, it is a dished shape. As the pressure plate cover tightens, it pivots on its fulcrum rings and flattens out to exert a force on the pressure plate and the facings. The transmission input shaft passes through the center of the pressure plate. Its parallel splines engage with the internal splines of the central hub on the friction disc. With engine rotation, torque can now be transmitted from the flywheel through the friction disc to the central hub and to the transmission. When the clutch pedal is depressed, the movement is transferred through the operating mechanism to the operating fork and the release bearing. The release bearing moves forward and pushes the center of the diaphragm spring towards the flywheel. The diaphragm pivots on its fulcrum rings, causing the outer edge to move in the opposite direction and act on the pressure plate retraction clips. The pressure plate disengages and drive is no longer transmitted. Releasing the pedal allows the diaphragm to reapply its clamping force and engage the clutch, and drive is restored.
Hi, I'm Bill Kiefer, Bill Kiefer Video Productions for Southern Oregon. If you have a need, we start at just $300. Until next time, give me a call at 541-973-0906.
Life's a foolish game. Do you ever feel the same? Well, maybe we could change, turn the ship another way. Feel it in the darkness, we're sailing right into those jagged cliffs. Yeah. Some say we've always been insane. Hey, life's a foolish game. Life's a foolish game.